kick off the next session, which essentially is going to be two case studies. The first case study is from S&C. So I invite Tim Qualheim, VP of Strategic Solutions for S&C Electric, on stage. I'm really excited about these case studies. They really get into kind of the technical challenges that that are presented at the utility level when deploying these technologies. So hope you guys will be excited as well. With that, I'll pass it over to Tim.
Thank you, Steve.
And the clicker's right over there.
Good deal. Thanks, Steve. Am I on? Am I on? There I am. All right. Well, good morning, everyone. Crowd's getting thin. This is a case study, and you know there's a lot of these presentations that are about pilot projects, that are about new technology, that are about things that are really exciting, but they're not really proven out yet. This is a case study of something that's relatively new, that has been proven, that's actually making a real difference at the moment. So, let me see, the green button, he says. There we go, reliability, reliability. We all obsess over reliability, and as you all know, we've spent a hell of a lot of money trying to reduce outages on the system. And of course, the reason we're doing this is this. The Lawrence Berkeley National Lab report that came out, I don't know, 12, 15 years ago, that's kind of become the standard for describing or explaining what the cost of an outage is, that's been relatively accepted by the industry, has been used in several rate cases, says that outages on systems cost our customers $26 billion a year. That's the reason we're trying to reduce outages, to reduce their costs. And you stop and think about it, and what are we actually doing? Well, over the years, you know what utilities are doing. They're replacing cable, they're replacing equipment, they're extending their tree trimming, doing a whole lot of things to incrementally reduce those outages. And a lot of them have actually gone ahead and started to use self-healing systems, which instead of incrementally take step change improvements in reducing those outages. This case study is about Florida Power and Light Company, and FPL has been installing those self-healing systems for probably 12 to 15 years now, and has made significant improvements in their outages. They're not the only ones. Just about everybody in the industry has been doing this, and to our credit, we've actually made some pretty good progress. This is the US SAIDI number. So back in 2006, it was 165 minutes. Now it's down to 119. We're actually going in the right direction, and that's great. But SAIDI is a measure of sustained outages, which in the US is basically any outage over 5 minutes. A few customers use different numbers, but 5 minutes is a sustained outage. What about those shorter outages, the momentary outages that are under 5 minutes? What have we been doing about those? And more importantly, what do those actually do to our customers? And you might find this one interesting. From that same report, momentary outages cost US electricity users $52 billion, double what the sustained outages cost them. Pretty interesting. We've been spending most of our money and most of our time working on those sustained outages, and we've been doing some things to reduce momentary outages, but we haven't been doing a ton with them. So a few thoughts. First off, part of the reason why we haven't done as much with them, if you think back 30 years or so, when there was a blink, a momentary outage, you had an electromechanical clock that was plugged into the wall. So it lost a second. Big deal. Nobody cared. We cared about the sustained outage. We cared if the power was out for 2 hours, but for that 1 second, for that momentary, we didn't care that much. Over the last 30 years or so, as you all know, we've had a proliferation of electronics, and electronics are a lot more sensitive to momentary outages. To be fair, that same clock today is a digital clock, and when it sees a blink, what does it do? It blinks back at you at 12 o'clock, and yeah, it only takes you 30 seconds to reset it. Doesn't really cost you a whole lot, so that probably doesn't affect that number a whole lot. But think about the drugstore on the corner. When they get their blink, their cash register shuts down, takes it 5 or 10 minutes to reboot, then it's got to resync with corporate. Half an hour later, they're back online, and they've lost all the sales during that half hour from all those customers that walked out the door. Another example was you move to the industrial sector. You called on a PVC extrusion company in Florida, And they had basically a 50 meter long, 50 yard long assembly line or processing line to extrude the PVC pipe. Electronic controls all the way up and down that line. Whenever they saw a blink, it shut down those controls, which screwed up the process. They had to shut everything down, clean all of the PVC pipe out of their process, restart the process. They showed me numbers from the previous year. That cost them over $1 million. So momentary outages have real effects on our customers. And I guess I'll put it this way. As we're moving into today's day and age, I'd say customers are coming increasingly intolerant of those momentary outages. So to try to figure out how to deal with them, you got to look at utility systems, and this is kind of a one-line diagram of what a typical utility feeder would look like. You've got a main line across the middle, and you've got all your laterals that come off of that main line. To deal with momentaries, you look at the protection schemes on those areas and decide how to address them. Now, if you talk to utilities, most of them will tell you that the momentaries, the ones we've talked to, about 20% of them come from the main line, and about 80% of them come from those laterals. So what FPL has done is on the main lines, they've started to add interrupting, reclosing devices in the middle or in 3 sections of the main line. And how this helps is if you have a fault on the far side, on the second half of the feeder, that device in the middle of the circuit interrupts that fault, and the people on the first half of the feeder don't see it. So it reduces momentaries and sustained outages in that way. But that's only 20% of those outages. The real focus needs to be on the laterals. And the laterals are all those circuits that go off of the main line. They're typically protected by a fuse. And let me explain a little of, actually, let me show you what happens when there's a fault on one of those laterals. Wow, a little louder than I thought it was going to be. So what you saw was that fuse saw the fault, and it operated and interrupted the fault. Took that particular lateral off of line, off of the circuit. Isolated it, cool, we did our job. Except when you talk to utilities, they'll also tell you that 80%, 70 to 80% of those faults on that lateral are actually temporary faults. They're a squirrel, a tree branch, something else. It's just temporary. What I did here was operated the fuse, took the lateral offline. Everybody on that lateral has now got a sustained outage. They're not going to be put back in power until the utility sends a truck out, replaces the fuse. So, in our zest, our zealousy to improve and reduce those sustained outages, FPL, like a lot of other customers, actually has gone to, in some cases, a fuse saving protection strategy, which means they set that breaker at the front end of the feeder to be faster than the fuse on the first shot. And let me show you what happens when that occurs. So you saw the difference. The fuse didn't operate, didn't isolate the lateral, but you noticed something else. Everybody else on the feeder saw a blink. So we improved our SAIDI, our sustained outage number, we improved that reliability, but we actually hurt ourselves on the momentary. We added momentaries to the system. FPL realized this, and they started to receive a lot more customers who just weren't happy with the momentaries, complaining about them. They decided they needed to do something about it. They looked at these options, they talked with us, and we actually came up with what we'll call a lateral reclosing protection strategy. So replacing all of those fuses on the laterals with a reclosing device. And let me show you what happens on that same temporary fault with a pretty simple. Like I said, replace the fuses with reclosers. FPL has made a commitment to do this across their entire system. They're the first utility in the United States that I'm aware of that's made any kind of a commitment like that. So that will reduce both the sustained outages and the momentary outages at the same time. to what else I wanted to talk on here. Okay, a few things. For those of you in the utility industry, you're looking at me and saying, Tim, reclosers have been around forever. What the heck are you talking about? Well, they have. But most utilities have not used them in any kind of a quantity for various reasons. First off, for years, momentaries weren't a big deal, so they didn't get pushed to do it. Second, they didn't have numbers like you've got from this report from Berkeley National Lab showing what the actual costs are to customers, so they didn't have the business case to go to regulators with, say, we want to do this. And thirdly, the reclosers that have been around for years, they weren't always all that inexpensive. You install them, you got to maintain them, there's a lot to it. What has made this more viable for FPL is a cutout mounted recloser that they're able to quickly put in place of the fuse that they've got, and a more economical recloser at the same time. In this particular case, if they save just 4 truck rolls, they pay for that recloser. Now FPL's momentary MAFI number is somewhere around, I think it's 8.7. So in FPL's case, they're going to pay for most of these reclosers within 1 year. And the beauty of that is they're in the second year, and the third year, and the fourth year, and that's where they're actually saving FPL money rather than costing money. So improving reliability and saving operating cost at the same time. This one's an educational thing. So if I had that feeder and I have 20% of my faults on the main line, 80% on the lateral, that's my MAFI, that's all my momentaries, right? Not really. There's another thing that happens that causes a problem called voltage sags that has the same effect on those customers as a momentary does. And what happens is you'll have a fault on one of the feeders. All 4 feeders are connected to the same substation transformer. When you have the fault on the one feeder, if it's a big enough fault, it actually sags or dips the voltage on that feeder. And since it's connected to the other 3 feeders also see that same voltage sag. What FPL determined was somewhere around a 70% voltage sag, 70% of normal, so 100% normal down to 70%. Somewhere around there is where it starts to affect those electronic devices similar to what a momentary outage does. So the second piece of this that makes this important is when FPL looked at their system, they said if I have 2 outages on the 2 momentary on the feeder and 8 on the laterals, I've got 5 of these voltage sags that have the same effect. So they really affect my customers more than I realize. So the second thing that FPL did was they decided they were going to replace their breakers on the feeders such that after they interrupt the fault, when they reclose, by the way, that voltage sag really comes from when you reclose, you're closing back into the fault, and usually they extend the closing time such that it will try to clear the fault more effectively. But what they've done is there's a new technology out there that's called pulse closing that doesn't reclose. It tests the line for the fault without reclosing, therefore it doesn't put that voltage sag back on the feeder. So the second thing that FPL has done is they're starting to use a pulse closing device right outside of the substations. I think they call it the O1 position. So it's kind of interesting. It's actually a neat thing. You've got some technology that's out there today that's actually going to make a significant difference. Right now, it's not pilot stuff. The commitment by FPL is actually as I said, a system-wide commitment. I think they're putting in 20,000 of those lateral reclosers this year. That's their plan. And their plan is also to accelerate and get this done across their entire system within 5 years so that they get those improvements, not only in the operational savings themselves, but that they're really for their customers to not have all those momentaries. And it's a big enough commitment that in this case, S&C actually committed to put a assembly operation in their service territory, which added jobs and brought their governor to town and got some good PR out of that. So to summarize, I'll go back through this real quickly. We've been putting a lot of effort on reducing sustained outages. Momentary outages are getting much worse than they used to be. Their effect is worse than it used to be, and customers are becoming more and more intolerant of them. And if you remember nothing else out of this short presentation, remember that the momentaries are getting more important. Remember that there actually are options today to deal with them, such as a lateral reclosing protection strategy, and that FPL is leading the way. They've made the commitment to install these kinds of devices across their entire system. They're actually raising the bar for the rest of us. That's it.
Thanks, Tim. Great. With that, we'll move on to our second case study so coming up on stage is Michel Lossier from NB Power and Bud Voss from ENBALA. Thanks.
Thank you.
What? Yeah. Actually, here, come on.
Great. Good to go? All right, thanks for having us. And thanks to ENBALA and Green Tech for this opportunity. It's great learning in this beautiful place. We'll be talking a little bit about renewable firming, a project we've done in New Brunswick, Canada on the Atlantic coast. And I'll put a little context in this. We'll be talking about integration, a load shifting project, and also a little bit on our vision. So I'll share a few things here, and we'll go quickly. Who's NB Power? We're a vertically integrated utility on the Atlantic Canada. So I'm going to speak from a perspective of a vertically integrated utility. Publicly owned, 394,000 customers, $1.6 billion revenue, winter peaker, residential rates 11 cents, industrial around 8. So just to get a perspective, well-diversified generation. We're currently at 32% renewable. We're targeting 40 by 2020. We're going to talk about a project here that's called Power Shift Atlantic. And we've heard a lot in the last few days, and I've learned a lot on value-add customers. This project is all about collaboration, transformation, and innovation. It's really about herding cats. 90% of the work is herding cats. Once you get there, you start moving. And we had the universities involved, 4 utilities, the SO, the suppliers, customers, a very, very progressive project and a lot of fun. And customers have said to us, and they continue to tell us as utilities, I want to see less fossil. I want to see more renewable. Don't raise rates and keep the lights on. And they look at the utility in the past and they'd say, okay, and I realize I'm preaching to the converted here, but they look at the utility and say, you guys figure that out. The reality in the future, and we all know it, is that we need to have a handshake at the meter. It's a new partnership. It's a new opportunity for us, and this is a little bit of what this project is about. So we're talking about a true partnership going forward. So the future of electricity is really about all of us. So I'm going to go through a few slides to give you some Canadian context in what we're doing, and we'll proceed through this. Canada, 64% hydro. We don't talk about this enough. We have a 12-cent rate average in Canada, 64% hydro, 15% nuclear, conventional steam. Winds at about 2%. It'll be at 4% in the next 5 years. We're starting to see some solar. We're starting to see engaged customers. But it's a pretty good footprint overall. And when we look at Canada, we're very proud of that footprint. When we look at New Brunswick, our province, just north of Maine, 800,000 people. Not a lot of growth, but there are shifts, rural to urban. There's things happening within our jurisdiction. We're going from 30% renewable to 40% renewable by 2020. Fossil fuel decreased 30 to 25. We do have a nuke. It's a 700 megawatt nuke. It's at 35%. So that gives a bit of a picture of what we're trying to accomplish. New Brunswick, you see Maine to the west and southwest. You see we're well interconnected with Quebec, with Maine, with Nova Scotia, and with Prince Edward Island. Now, this slide says a lot. I'll go quickly. But we peak at 3,100 megawatts. We've been at 1,000, all right? Of that 3,100 megawatts, there's 1,500 megawatts of electric space heating and 200 megawatts of coincidental hot water heating going on. We rent 250,000 electric hot water heaters. That's what's somewhat unique about us and what we're presenting here today. There's a tremendous opportunity in that to offset the need to build, to better integrate renewables, and to reduce our fossil dependency. So how do we interconnect this with intelligence, and why would customers want to play in that? Nova Scotia, if you see south of us, peaks at 2,000. They have more customers than we do, but they're less electric heat. We only have about a 20% gas penetration. So there's opportunity. The other thing, we've been at 900 or 1,000. we balance about 500 megawatts of wind. There's a lot of wind in the Maritimes, okay? There's an opportunity there, but we've got to be able to balance this stuff effectively, and we need to look at new solutions to do that. And that's what we'll talk about here. So we supply PEI, Prince Edward Island, and we're well interconnected with the States, and we have some great interdependencies and interconnections. That's the coldest day of the year. Like minus 32, it's cold, okay? This is one of those days when everyone gets up and cranks up the heat, and things are happening real fast. We had about 4 feet of snow last winter, so, and I think some people in this room would have seen that in the Boston area as well. So we peak at, this is one day. You got the 2850 peak on a Thursday night. You go down to 2460 at 2 in the morning. We go up 700 megawatts in 5 hours. That's the characteristic of our system. So what's happening there? We have 200 megawatts of electric hot water heating going on there. We have electric space heating. There's opportunity here. We want to offset the need to build. That's the vision of the company. We've just taken on the efficiency agency. We want to offset the need to build, better integrate renewables, and run this system more effectively and less fossil. Because at that peak, we're burning oil. We're paying 18 to 20 cents. We're getting 11 back. We burn oil 20 days a year. It's not great. We're not proud of that, but we have to do that, and we will reduce that dependency. But you know, it's really a conversation with the customer about why we would want to do that. And when we did this project, we talked about this. And people really engaged in that. And it's a new experience for the customer to be part of that. And even let us have the water heaters and different loads to make some of this happen. So the bottom line, this is a bit of a crude representation. But obviously, if we can pick some of those peaks, put them in the valleys, and we start to see a new load shape. So that's a typical home in New Brunswick, what you see here. Electricity matters in New Brunswick, and it matters more than most jurisdictions in North America. We are the second most intensive jurisdiction in North America for electricity demand because of space heating. Our rates are low and competitive, but the bills are high. People don't pay attention to the rate, they pay attention to bills, right? So we do have to pay attention to the whole thing. So 60% space heating and cooling, and most of that's heating. Water heating, 20%, and then the rest. So that's our opportunity. We're working with Siemens, we're partnered with Siemens, we're working with ENBALA, we're looking at ILM VPP solutions to try to make some of this stuff come together. So Power Shift Atlantic, what is it? It's a renewable firming project, and I'll go through that quickly. But the bottom line is it's really interconnecting with devices like water heaters, like building systems, HVAC, like ETS, bricks. Steffes is part of this, ENBALA is part of this, Integral Analytics, and interconnecting through an open platform virtual power plant to better integrate renewables. And the bottom line is customers were very favorable to this. And again, customers still have hot water. They still have heat. They still have it's business as usual. This is flexible load. It just makes too much sense. I think we all know that. We know there's a lot of complexities to doing this, and we don't have it all figured out. But what we heard this morning in the last few days, this is not simple stuff. It sounds great at the surface, but when you get right down to the details, it gets dirty and ugly. We know that. So what we're doing, we determine if shifting patterns in energy consumption through load shifting can enable utilities to effectively integrate renewables. Is it cost effective and reliable? How do these shifts perform in sync with system balancing and forecasted wind power? And to really understand the customer's role and to bring them for a new experience, because it's really a new experience for a customer. So we did that. Some of the players, it's an NRCan funded project, Clean Energy Fund, for utilities, PEI, Nova Scotia Power, a local distribution company, NB Power, UNB, University of New Brunswick as well, and other players. But the PM and the integration, Stantec, Acreon, Leidos, aggregators, ENBALA, UNB, Integral Analytics, and Steffes. So we had all those aggregators. And the end-use connectivity, Sequentric, Dimplex, Tantalus, Bell Alliance, Steffes, and ENBALA. So again, a lot of interoperability. We had an open platform VPP that we created. And basically, it was watching wind forecast. Day ahead, hour ahead, 10 minutes ahead. And we were watching loads, day ahead, hour ahead, 10 minutes ahead on an ongoing basis. And we intercoupled the two. So the bottom line here is you got convention. This is just a very simple, what we had in the past, conventional generation equal customer demand. Now we've got conventional generation plus wind equals customer demand. Conventional generation takes the hit, right? And we all know that. So you don't want to be spilling water and integrating wind. And if policy is too aggressive, that's what happens. And we know that there's things like that happening, negative pricing, spilling water at times. So how do we get this right? And what part can we engage the customer to get some of that flexibility to really relax and take the pressure off the conventional generation? So how can we do load smoothing? So again, what we built here was a virtual power plant, an EMAS system that took wind forecast, day ahead, hour ahead, 10 minutes ahead, and we had these aggregators looking at loads, day ahead, hour ahead, 10 minutes ahead. Connected the two, demonstrated that this can work, okay? It's early days. It's still a little expensive. That aggregation is not quite where it needs to be as far as the interoperability needs to be developed, and end-use products like water heaters need to come down in price, controllable water heaters. There's 40 million electric hot water heaters in the Northeast, in the rural areas. It just makes too much sense to have that as a battery down the road. So solutions are beyond borders. I firmly believe that. So that's a bit of what we did. So what we ended up with was 17 megawatts of connected load at about 1,400 customers, which is quite exciting. And you know, we had no incentives for customers in this project. We engaged them. After a while, they did start asking, so what's in it for me? And we had a little bit of that going on. But generally, really excited about the new experience and being part of a new system. Really excited about seeing utilities working in collaboration. And really excited about seeing more wind and less fossil over time and being part of that. But you know what they told us? We don't even know what's going on. I have hot water and heat. I'm not sure what's going on. I'm glad to hear it. Talk to us. And we weren't talking to them enough. They wanted a conversation with the utility. See, this is all about the customer. So we had to start telling them more about what they were actually doing. And they were really interested in that. Although it was small, if we upscale it, it could be huge. So again, some of the loads we had, Steffes, numbers there, a megawatt, 94 residential customers. Dimplex, 138 residential customers, 353 unit devices. 1 megawatt, and those are bricks. You heat bricks 8 hours a day. What's the best 8 hours? If the wind doesn't blow for 4 days, heat them in the valleys. If the wind blows, try to line it up with the wind. See, we have that luxury as a VIU, vertically integrated utility, to take the whole picture end to end. And I realize it can be more cumbersome than that in certain places. And then we've got the large bricks on the bottom with Steffes. That's 400 kilowatts in a school. And you know, the kids did school projects around this. These are brick heaters, heating hot water, lining up to the wind. Pretty cool stuff. Obviously with ENBALA, a lot of work, 30 commercial customers, I think in the order of 2,000 different connected loads, anywhere from 3.5 to 5.5 megawatts of shiftable load, and instrumented water heaters as well as non-instrumented. And the answer is in instrumented water heaters, but price points have to come down. Yeah, existing baseboards, that's a typical look in a home. I mean, they've been doing this in the UK for years, for peak shaving, not for renewable firming. But you know, there are new products. There are new flexible loads. There's going to be new flexible loads coming out. And we need to take advantage of that. And we need to think ahead. We need to bake in some interoperability. Very important. People like that heater on the right-hand side because that little fan, it felt a little more like a wood heat versus the resistive heat. And better experience for them. Just a couple of pictures here. Those are the schools, the bricks in the schools. Those are HVAC units, air units. So really what we're talking about here, to our opinion, is a new customer experience. And most important, as a utility, we've always had technology projects for customers. We've always built technology projects for customers. These are customer projects with technology. This is an entire transformation, and I just said a mouthful, but if you really go there for a second, it's a customer project adding customer value for what the customer wants with technology. These are very iterative projects. It's no longer we're going to figure everything out and bring the solutions and that's it. It's an active customer. It's an educated customer. Some will be set it and forget it, absolutely. And some won't want to play, fine. But for the most part, we need to really work at this. So it's a new partnership with new solutions, and I know most people get that here. But again, that handshake, I see that handshake at the meter, and we really have to do this together going forward. New experience for customers, changes in the air. You know, we sold that experience to customers and their ability to promote that. They like that. They put that in your annual reports. Municipalities love this stuff, the smart cities. We're selling an experience. We're not just selling a commodity here. It's a renewable experience. People love this stuff. So I think working with ENBALA, we really had the opportunity to demonstrate some of this stuff. CSR, so the bottom line here, I think at the end of the day, you look at this slide, 80% of the conversation in our utility has been on the left-hand side for the years past. 80%, 90%, 10% on the right, we're a monopoly. The bulk system meets DER. So what we're seeing in our utility, because our vision really is to have less fossil, to have more renewables, and to offset the need to build, we're putting a lot more focus on the right-hand side. That conversation's shifting. I'm not saying it went from 80-20 to 20-80, but I think it's 50-50 right now. So at the board, at the executive and the board level and through the organization, we need to keep the lights on. We need to innovate for the future, and we're in austerity like everybody else with rate suppression, aging infrastructure, and limited growth. That's a hell of a challenge, and I think we all know that. We're working with Cotter International. We recently had 60 people in a room. We're doing the Accelerate program. I really highly recommend that book to everybody in this room. A utility looking for transformation. How do you take an organizational structure and try to move fast? There's some suggestions in that because we're all going to be challenged with that. How do we move faster? So again, a couple of things I just wanted to share. It's been exciting. I think an exciting project for us, and working with ENBALA has been great, and I think Bud's going to come up and share a few slides with you. Thanks, Bud.
Great, thank you. Thank you, Michelle. First of all, I want to say what a pleasure it has been over the last couple of years working with such a forward-looking customer as New Brunswick, Energy New Brunswick. We've been involved in the Power Shift Atlantic program for, as I said, many years, but I have to say the work that Michel and his team and the entire New Brunswick Power team has done has truly been phenomenal, because they actually embraced this idea of there's a different way to do this. So I'm going to talk for just a few brief moments about what ENBALA actually did inside of this program. As was said, we had about 5.5 megawatts of flexible capacity. And that's a very interesting term when people hear the word flexible capacity. What does that actually mean? And how do you actually achieve it so that customers have literally a zero impact experience? So a lot of what ENBALA is all about, if I can get the clicker to go here, is really about building, first of all, that platform approach for being able to do control, forecasting, and finding the asset flexibility. Now, what that means is we actually do deploy a piece of intelligent software locally at a customer's facility, and that intelligent learning software is constantly looking for the flexibility within the load. Now, in our case, on this program, we were solely focused on loads, and we were solely focused mostly on commercial type installations. In fact, we have a lot of schools, a lot of hotels, some hospitals, and a couple of industrial facilities. The second layer is to then layer in the intelligent control. So once we have the asset flexibility and we have the software in place that's harnessed that flexibility, we bring control locally for the customer. Another key aspect to this is we can't impact customer comfort. We can't impact their day-to-day operations. We fundamentally believe that we have to fit within the operating constraints of that particular customer. So if you're a large water processing facility, such as clean water or wastewater, you're going to move 80 gallons of water a day. The question is when and how, and can we use different elements of energy in order to actually move that water? But that customer wants to move the water. If you're a school, you're going to operate in an environment where the students are comfortable, and you're going to do that during the day. The question is, again, how do you get there? How do you heat the building? How do you cool the building in order to actually get there and maintain that and find the flexibility? That's the key to that second layer, is the local control aspect and optimization that we actually execute locally for the customer. And then the last piece is we aggregate it into a network. We all kind of understand, I think, the concept philosophically that when you build a network of flexible assets, you can then do very intelligent things with that network. And that's what we actually did here, was we then delivered that as an aggregate to the VPP as an aggregate grid service. So now think of, again, 30 facilities, over 2,000 individual devices, all performing their dance together. One of our CTO sometimes thinks of this as a flock of birds. And it's a flock of birds where every individual bird is slowly moving around, but that flock of birds is going in the same general direction. And that's the grid service and the network service that we ultimately deliver. Some of the examples of where we've done this or what we actually do. Interesting story about ENBALA, because we started in the world of doing frequency regulation, frankly a very difficult problem. And it was New Brunswick Power that came to us and said, could you apply that same technology in a different way? So it's actually a very different problem. And so what do I mean by that network? And we show this slide a lot to kind of impress upon the fact that the network itself is this concept of all of these individual loads. And when you have loads here, what we see are actually a series of binary loads, literally fans, pumps, motors, things that we're turning on and off. They only have an on or off state. We can't vary them. But when we start to bring them together, you can see they start creating a shape. And what we're doing is we're operating those loads in and out against the customer constraints, and we're matching that shape of the red line below. That red line is the grid service that we have to deliver. That's the forecast that's been delivered to us by New Brunswick. And then they've told us, you need to follow this curve, so make the loads follow this curve. And so we do that on an ongoing basis. And you can see as I kind of build up the network here, you can see how it automatically begins to match that. And that's what the ENBALA software is actually doing on an ongoing basis. So now customers are not being impacted. They're operating within all of their constraints, yet we're able to aggregate and deliver all of these back to the utility as a cohesive grid service. So what did that look like for New Brunswick? As we talked about, 2,000 individual devices. So bringing in and networking, and it is dirty. I mean, as Michelle said, it gets dirty when you walk into the building and you say, where are the loads, where are the systems, how do we hook up to them? We're actually quite proud that we did all of this entire deployment in partnership with New Brunswick Power. We did it with local contractors. We did it with the people that the buildings themselves used as their local contractors. We did not ever send an ENBALA electrician to the Maritimes. We never had to actually do any of that. We used the local labor, the local workforce. That actually enhances back to the customer experience part that Michelle was talking about, because this was about New Brunswick. And so we were able to integrate and bring all these devices together. And this system actually runs on a 24/7 basis. We monitor and run this system out of our Network Operations Center in Vancouver, British Columbia, all the way the other side of Canada. But it literally runs on autopilot. It basically sits there, gets a forecast coming from the VPP, as Michelle said, day ahead, hour ahead, and then 10 minutes ahead. And it's constantly adjusting over time. And we basically deliver that as a single point to them. This is what it actually looks like in operation. The previous slide was the kind of the PowerPoint version of the network coming together. This is the actual operation. This is what our operators look at every single day. And I'm not going to take you through each individual curve. I'm going to only take you through two very important ones, and it's that sawtooth at the top. That sawtooth at the top is the actual energy forecast that's been delivered to us that all of our loads need to actually, if you will, burn through in a 15-minute period. So the red line, which you can barely see, is the signal that's been delivered to us by New Brunswick. They basically say, get to this endpoint every 15 minutes. And on an energy basis, we're actually optimizing for that every 4 seconds. So what you see down below is the individual behavior of the actual aggregate network moving around very, very gracefully, like that flock of birds, in order to make sure we're hitting that 15-minute target every 15 minutes. Again, customers are not affected by this. We operate within their constraints. And now what we have is we have a highly flexible resource. I do want to underscore one other point. A lot of people think of this new world of distributed energy as enhanced load shedding. This is far from enhanced load shedding. The reason why this is far from that is because in some cases, we will take a resource and we'll speed it up. We'll tell a building to cool faster or heat faster. We'll tell a water heater to actually move water faster. So what we're actually doing is we may be consuming a bit of energy because we have another device in the network that's doing something in the other direction. This is far from load shedding. But this is an intelligent grid service that's now being used to firm a renewable asset, which has huge value to New Brunswick, huge value to the customers of NB Power. And do you want to summarize? Fantastic. Thank you, Michelle.
Thank you, bud. Mm-hmm. Thank you. One of the things that through the project that we found working with ENBALA was we maintained the customer relationship. And what we really respected was when they showed up, they played that well. We had tri-party agreements, and we were able to maintain that relationship, but then add a lot of value to our customers. And that was extremely important because we were concerned about that going in. And I think most utilities do get concerned about that. But what I found with ENBALA is we really had a good, solid partnership with the customers. We added value, and it was, like everybody's, I think everybody wants to be first to be 10th in this game. So they had to build the confidence in some customers that there are other water treatment plants doing this. Okay, can we talk to them? Yeah. So there was a good conversation there, because we have to make customers comfortable with this, because really at the end of the day, it's all about the customer. And I think that's the message we want to send. The bottom line with all of this VPP performed. It performed well. We went to 10 minutes. I think we could get better than that. ENBALA does better than 10 minutes. But we wanted to do this, and we wanted to demonstrate it end to end. We had an open platform VPP. We had 4 aggregators interfaced with that open platform VPP. Interoperability needs to develop. It's still a little clunky and expensive, but it's coming. So we need to continue to develop standards. That's really important. Customers favored a good experience. Interoperability and standards, it's just the right thing to do. We as an industry need to have sustainability in every one of our conversations. That's what the new generation is going to buy. What I showed at the front end of this about peaks and valleys and better integrating renewables, people like that stuff. I don't know, we don't have to get too complicated. We can get real complicated within. When it gets to the customer, we got to keep it real simple, but sustainable. And we need to do that collectively. So it's really difficult to speak about technology without speaking about the customer. So end device costs need to come down. Interoperability is still a little expensive. End device costs need to come down. But what we determined here is upscalability with this and baking this into the system. We rent 250,000 electric hot water heaters. We replace 15,000 per year. Put the right ones out there. Start cooking this thing so 10 years from now, we have a fleet of 250,000 electric hot water heaters that we may integrate ourselves with technology. Then we get the right price points. So I think that these edge solutions are a big part. This is not the whole solution. It's not the be-all, end-all. It was a good R&D project. It's not commercial grade, but it worked. It was fun. And I think we drove a good customer experience. But at the end of the day, what I heard in the last few days that really stuck with me is it's all about a new customer experience. I really believe we have to start getting away from a commodity conversation. And I know that's still important, but it's broader than that. If you have an electric vehicle, you don't have to go to the gas station anymore. You plug it into your house, you got vehicle to home. When the lights go out, that's a whole new experience. We're not quite there yet, but we're getting there. And maybe that's what we're selling. Maybe if we stop talking about commodity and we start talking about that stuff, maybe people will even pay more. I pay $400 a month for my phone bill. I used to pay $100. Why do we do that? So what is it that we can do as an industry to start that conversation and drive value? And people will want to play in this game. So anyhow, I hope that was
great.
Good. Thanks.
Thank you. A round of applause for Michelle and Bud and for Tim as well. I know you all are, we're cutting a bit into the lunch hour, so if you guys have any Q&A for these folks, if you guys don't mind staying up here for a bit, and then we'll reconvene back here at 1:15 for our afternoon sessions. Thank you. Thanks, guys.